Right now, you are moving at 1,000 miles per hour. You don't feel it. You don't see it. But you are hurtling through the vacuum of space on a giant spinning marble. Now, imagine that marble hits a wall. In the next fraction of a second, the atmosphere, the oceans, and everything not bolted to the bedrock continues to move at supersonic speeds. This isn't just a bad day. This is the instant rewriting of the laws of biology and geography. This is the day the world stands still, and everything on it keeps going. Welcome to Deep Science Explained. We take the fundamental constants of our existence for granted. Gravity keeps us down, the sun rises in the east. But the most vital rhythm of our lives, the rotation of the Earth, is actually a fragile momentum born 4.5 billion years ago. If the Earth stopped spinning, we wouldn't just lose our clocks. We would lose our protection, our shape, and eventually, our air. It is the ultimate what-if scenario, a deep science mystery that peels back the curtain on how thin the line is between a thriving civilization and a frozen, irradiated rock. How long would you survive? What would happen to the literal shape of the planet? And could humanity endure a year that lasts forever? Let's start with the immediate aftermath. Physicists call it inertia. Imagine you're in a car going 100 miles per hour and you slam on the brakes. You fly forward. Now, imagine that car is 12,000 kilometers wide and traveling 10 times faster than a commercial jet. At the equator, the Earth spins at roughly 1,600 kilometers per hour. If the solid ground stops, the air doesn't. But here's where it gets crazy. The atmosphere would instantly become a planetary-scale supersonic windstorm. We're talking winds 4 times stronger than the most powerful hurricane ever recorded. It would literally peel the topsoil off the continents. Skyscrapers wouldn't just fall, they would be shredded into dust and carried thousands of miles away. Even the oceans would feel the jerk. A massive global wall of water, a tsunami of biblical proportions, would sweep from the equator to the poles. What if you were standing at the North Pole when it happened? You might be the only person to survive the first 10 seconds. Since the rotational velocity at the poles is near zero, you just see the horizon suddenly tilt and feel a terrifying breeze. But for the rest of the world, it's an instantaneous wipeout. To truly grasp the scale of this catastrophe, we have to look at the ground itself. We think of the Earth as a solid, unyielding rock, but on a planetary scale, it behaves more like a viscous fluid. Because the Earth has been spinning for billions of years, it has flattened out into an oblate spheroid. The centrifugal force generated by its rotation pulls the planet's mass outward at the equator, creating a bulge about 42 kilometers wider than the distance from pole to pole. If the Earth stops spinning, that force vanishes. Gravity, suddenly unopposed, begins to pull that excess mass back toward the center. This would trigger the most violent seismic activity in history. The crust would buckle and fold. Mountain ranges would collapse as the planet attempts to reshape itself into a perfect sphere. In the deep science explained view of geology, this is a total structural reset. The ground wouldn't just stop, it would shatter. Every tectonic plate would grind against its neighbor with enough friction to liquefy the bedrock. As the land fractures, the water undergoes an even more dramatic migration. Currently, the Earth's rotation holds the oceans in place at the equator. Without that spin, the gravity at the poles, which is slightly stronger because the poles are closer to the Earth's center of mass, begins to pull the world's water toward the top and bottom of the globe. Imagine the entire Atlantic and Pacific Oceans draining away from the tropics. In a matter of hours, the Caribbean would become a desert. The Amazon River would flow into a dry basin. Meanwhile, the northern and southern hemispheres would be swallowed by 2 gargantuan mega-oceans. London, New York, Tokyo, and St. Petersburg would vanish under thousands of feet of salt water. The only dry land remaining would be a single continuous belt of mountains and former seafloor circling the equator. This would be a new Pangaea, a wasteland of salt flats and jagged rock separating 2 disconnected polar seas. But even if you managed to survive the winds, the earthquakes, and the flooding, you would face a silent killer from above. Deep inside the Earth, there is a core of solid iron surrounded by a swirling ocean of liquid metal. This motion, driven by the planet's rotation, creates a geodynamo that generates our magnetic field. This field is our invisible armor. It deflects the solar wind, a constant stream of high-energy particles from the sun that would otherwise strip away our ozone layer and cook our DNA. If the Earth stops, the dynamo stalls. Our magnetic shield would flicker and fade. Suddenly, the sky wouldn't just be a source of light, it would be a source of lethal radiation. This is where the mystery of the universe gets dark. Without a magnetic field, the solar wind would begin to erode our atmosphere, sandblasting the oxygen and nitrogen away into the void. We would watch our blue sky turn a thin, sickly violet, and then finally go black. Now let's talk about the passage of time. On a spinning Earth, the sun rises and sets every 24 hours. If the rotation stops, the only thing determining day and night is our 365-day journey around the sun. This means a single day now lasts an entire year. For 6 months, you would endure a long day of unrelenting, scorching sunlight. Without the cooling effect of the rotation to distribute heat, temperatures at the center of the day side would soar to 100 degrees Celsius or higher. The remaining water would boil, creating a thick, suffocating greenhouse effect. Then, as the Earth slowly orbits, you would enter the long night. For 6 months, the sun would vanish. Temperatures would plummet to -55 degrees Celsius. The very air you breathe might begin to freeze and fall to the ground as carbon dioxide snow. Life as we know it is not built for these extremes. Agriculture would be impossible. The food chain would collapse within weeks as the plants on the day side burn and the plants on the night side freeze in total darkness. Deep Science Explained asks us to consider, could humanity survive? Perhaps, but not on the surface. We would be forced to become a subterranean species, building cities deep into the crust to escape the radiation and the temperature swings. We would have to live in the twilight zone, the thin, moving sliver of land between the scorching heat and the freezing dark. This line, known as the Terminator, would move at a walking pace as the Earth orbits the sun. We would be a nomadic civilization, forever chasing the dawn to stay within a livable temperature range. But even then, the psychological toll would be immense. Our internal biological clocks, our circadian rhythms, are hardwired into the 24-hour cycle. In a world of eternal light or eternal dark, our minds would begin to fracture. We are creatures of the rhythm, and without it, we are lost. As the philosopher and scientist Blaise Pascal once said, "The eternal silence of these infinite spaces frightens me." In this new world, silence would be all that remains. But in that silence, we find a profound revelation about the mystery of the universe. Our lives are not just a product of biology, but of motion. We are the children of a spinning top. Every heartbeat, every harvest, every dream we've ever had is synced to a 24-hour rhythm we didn't even realize was a gift. Deep Science Explained shows us that we don't just live on Earth, we live with its momentum. We are part of a cosmic dance that began billions of years ago, when a cloud of dust and gas collapsed under its own gravity, spinning faster and faster until it formed the world we know. So what would happen if the Earth stopped? We would realize that we are passengers on a cosmic machine, so finely tuned that even a slight hesitation would end the human story. But there's a final reflective twist. The Earth is slowing down. Because of the moon's tidal pull, our days are getting longer by about 1.7 milliseconds every century. This is due to tidal friction. The moon's gravity tugs on our oceans, creating a drag that acts like a slow-motion brake on our planet's spin. Eventually, billions of years from now, Earth will become tidally locked to the sun, just as the moon is locked to the Earth. We are living in the golden age of the spin. We are living in the brief window of cosmic time, where the day is the perfect length for life to flourish. The next time you watch a sunset, don't just see the light fading. Feel the Earth tilting you away from the star that feeds you. Feel the 1,000-mile-per-hour wind that gravity is kindly holding back for you. Recognize the incredible complexity of the geodynamo humming beneath your feet and the massive, invisible bulge of the equator that holds the world together. Maybe reality isn't just what we see. Maybe reality is the perfect balance of forces, centrifugal force, gravity, and inertia, that we are just lucky enough to experience for a brief, spinning moment. We are not just standing on a rock. We are balanced on a miracle of physics. I'm your host, and this has been Deep Science Explained. If this journey into the abyss moved you, hit the like button and subscribe. It helps us keep the lights on and the world turning. In our next episode, we'll uncover something even stranger, the Big Rip theory. What happens when the universe itself decides to tear apart at the seams?